Okay. So, in the previous topic, we saw how to create complex scales or compound scales, and especially Likert scale. But this is only one approach to the measurement. There is another approach to the measurement, and this second approach is called factor analysis. And the question again is why? So I will switch to the questionnaire. Where is the questionnaire? Maybe here, yes. Question. So this scale one, scale A, scale for the optimism, consists of only 6 items. There are only 6 items in this scale. In scale B, there are 7 items, but in scale C, there are 20 items. So here, it is possible all these 20 items to form only one scale. But it is also possible these 20 items to form more than one scale, maybe 2 or 3 or 4 subscales. Usually, when we use questionnaire, we have so-called key of this questionnaire. And this key includes this correspondence between items and subscales. We already know which item to which scale belongs. But sometimes there is no key to the questionnaire, and maybe when you create new questionnaire, maybe in the beginning you don't know, or you will not know which item to which scale belongs. And then we need factor analysis. So I will close this presentation about simple and complex scales, and we'll start new presentation about factor analysis, topic number 6. Usually, factor analysis has 4 steps. One step is preliminary, and other 3 steps are basic, essential for the factor analysis. Unfortunately, in PSPP, there is no preliminary step. Factor analysis in PSPP begins with first basic step. So I will show this preliminary step in SPSS. So we choose analyze dimension reduction factor. In PSPP, there is not this intermediate step dimension reduction. From analyze, we directly choose factor analysis. But in SPSS, after choosing factor analysis, of course, we have to move these 20 items from left to the right. I will move here in PSPP, but first of all, I will choose with my right button of the mouse. I will uncheck perfect preferred variables name. We will select items from C1 to C20. Okay, C20, okay, and then move to the right. So after that, in SPSS, there is button descriptives, and there are two options: anti-image and KMO and Bartlett test of sphericity. And when we press OK, first we have to see this KMO. This is Kaiser-Meyer-Okin measure of sampling adequacy. And this measure, the interpretation of this measure is the same as for the Cronbach's alpha. So the intervals are the same. Here we have 0.9, 0.87. 0.87 is here between 0.8 and 0.9, and this is good sampling adequacy. That means that all these 20 items form at least one scale. We don't know yet how many scales are there, but at least one. We are sure that exists at least one scale. After that, in this anti-image correlation, here we have values marked with A, and here there are footnote, and A means measures of sampling adequacy. This Kaiser-Meyer-Okin measure of sampling adequacy is for all items altogether, and these sampling measures of sampling adequacy are for each item separately. But the rule is the same. If the value is below 0.5, the sampling adequacy is unacceptable. If the value is larger than 0.5, the sampling adequacy is acceptable. So here we have good sampling adequacy, and here we can see that all values are above 0.8. So all for all items, sampling adequacy is at least good, and for some items is excellent. That means that we can continue with first basic step. If here the sampling adequacy is unacceptable, or here for 1 or 2 or a little number of items, the sampling adequacy is not acceptable, we must remove these items. If there are values below 0.5, we must remove the correspondent item from our analysis. Unfortunately, this step is not possible in PSPP. So we will use all items. We don't know here whether one or two or more items are not appropriate for the factor analysis. After that, we can continue with the first basic step. This is identifying the number of the factors. How many factors are there? Because these factors are so-called hidden factors or latent factors, these factors are our scales. If we obtain, for example, two factors, that means that there are two subscales. Or if we obtain four factors, that means that there are four subscales. So the question about the number of factors is the question about the number of subscales. So we can make this in PSPP. For this purpose, we have to press this button extraction. And here we can make some changes. First of all, in this field, analyze, we have to switch and choose correlation matrix. Why? Because when we choose covariance matrix, then we work with initial values. But when we choose correlation matrix, then we work with z-scores. So when we perform factor analysis, it is recommended to use standardized value. Do not use the initial values of variables, but to use standardized values. So here we must choose correlation matrix. And another choice is script plot. Script plot is one very important plot, and we will see how to use it. Before press continue and OK, here we have method for factor extraction, and by default the method is principal component analysis. Principal component analysis is most popular method for factor extraction, and very often in different publications, especially in different publications in psychology, there is a footnote PCA and I will say what is here after the end, but for now, PCA, this is principal component analysis, the main method for factor extraction. After that, we can press continue and press OK. And let's see the results. The results are here. First, this table, total variance explained. This table has 6 columns, but these 3 columns are identical with these last 3 columns. Here we have total, also total, percent of variance, cumulative percent. But in the left part of the table are all 20 items. All 20 items are here. Here, in the right part of the table, we have only 4 rows. Only 4 rows means that the software is revealed or is obtained 4 factors, 4 subscales. but it is possible the real number of factors or the real number of subscales to be different. And the exact number of factors is defined by this plot, the script plot. Script plot has two parts. One part is very sharp here, and other part is very flat here. And to define the number of factors, to identify the number of factors, we use so-called elbow rule. We use breaking point. Here, the elbow is on 3 factors, not on 4. So the better decision is to choose 3 factors instead of 4. And after that, we must repeat the analysis. We must choose again analyze factor analysis. And then here is in extraction, we have to choose number of factors and type 3. Then press continue, then press OK, and let's see the results again. So let's switch to the presentation. So 4 factors, as I already said, and here is elbow rule, breaking point in this plot, in this chart. Script plot shows that the better decision is to choose 3 factors instead of 4. Here we fixed 3. And before the interpretation of the factors, we must or we usually make so-called rotation, because since we already obtained 3 factors, our next task, the next step in our analysis is to identify the correspondence between items and factors. Here is so-called component matrix, and there are different rules for correspondence, for association between items and factors, but most popular and most widely used rule is to take the biggest absolute value on each row. This means that plus or minus doesn't matter. We take only numbers without sign, and take biggest number in each row. So interested corresponds to the first factor, to the first subscale, because here we have the biggest absolute value on the first row. Upset also correspond to the first factor, scared also correspond, and so on. But it is possible, and here you can see, it is possible to have 2 or more biggest values. Here we have minus 0.43. Here we have 0.44. These 2 values are not equal, but very similar, very close, and this is questionable. Determinate could be associated with factor 1, but could be associated with factor 2. To avoid this obstacle, usually we perform another transformation called rotation of factors. So, to perform rotation, again choose analysis, then factor analysis, then rotations. There are different methods for rotation, but most popular and most widely used is Varimax rotation. So I already said that in publications for factor analysis, usually there are footnotes, which is PCA and Varimax rotation, because this combination is most popular. And I will choose here Varimax, continue. After that, OK. And after that, I will analyze directly the rotated component matrix. And then I already said that there are 4 different rules. I already mentioned the first rule, but now I will show you all 4 rules. And let's start with the rules. Rule number 1. We take the maximum absolute value in each row. Thus, we will associate the variable to the most important factor. Because these coefficients in this matrix are standardized coefficients, since we use correlation matrix, I already said choice of correlation matrix means that we work with standardized values. And then this coefficient here are standardized coefficients. That means that these coefficients show the importance of each factor to the item. So in the first row, our first factor is most important factor to the interested. Second, a third factor is less important, and the second factor is the last, because its coefficient is the lowest coefficient in the first row, and so on and so on. So this is rule number 1. We take the maximum absolute value in each row, and thus we associate the variable to the most important factor. Rule number 2. We take the maximum absolute value in each row of rotated component matrix only if it is larger than 0.5. Why 0.5? Because these coefficients are also correlation coefficients. They are standardized correlation, but they are also correlation coefficients. And when we take the correlation coefficient which are larger than 0.5, thus we associate the variable to the highly correlated factor. This was rule number 2. Rule number 3. Again, we take the maximum absolute value in each row only if it is larger than 0.7. Why 0.7? This is because if we take 0. Sorry, not 0. If we square correlation coefficient. So if we instead of correlation coefficient, if we take square of correlation coefficient, this new coefficient is called coefficient of determination. And this coefficient of determination show percentage of variance of the item, which is explained by the factor. So if we want the factor to explain more than 50% of variance of the item, we have to calculate square root. And here R must be larger than square root of 0.5, which is approximately 0.57. So when we take maximum absolute value in each row of the rotated component matrix, only if it is larger than 0.7, thus we will associate the variable or the item to this factor, which describes more than 50% of the total variance of the item. And the rule number 4. The rule number 4 is that we again take the maximum absolute value in each row of the rotated component matrix, but only if its squared value is larger than the half of the extraction communality. Extraction communality or extraction communalities are here in different table. Here we have table communalities, and we have column extraction. And these numbers here show the percentage of variance of the item explained by all factors together. So here, 51% of the variance of interested of this item, 51% are explained by all three factors together. And 54% of total variance of upset are explained by all three factors together, and 75% of total variance of scared are explained by all three factors together, and so on and so on. So when we take maximum absolute value in each row, only if its squared value is larger than the half of communality, thus we associate the variable to the factor which describes more than 50% of the variable variance explained by all factors together, not 50% of total variance, but the 50% of the variance explained by all factors together. So after performing the rule number 1, the correspondence between items and factors is this. And here I put these items in different columns: factor 1, factor 2, factor 3, and all items which are associated with factor 1 are here in the first column. Here are the items corresponding to factor 2, and so on. If we perform rule number 2, sum of items disappear because for some of items, maximal absolute value is less than 0.5. So this is the list of items for each factor. If we perform rule number 3, more factors disappear because the absolute value in these rows are less than 0.7, and here 3 lists are shorter than in previous case. And if we perform the rule number 4, we have to compare this component, this coefficient, but squared, with the half of extraction communality. And then we also have here a list with factors, list with items for each factor. So this was the second basic step. First basic step was to identify the number of factors, and we identified 3 factors. The second basic step is to identify the correspondence between items and factors, and we just did it. We have lists with items for each factor. And the third basic step is to give names of this factor. Now we have here factor 1, factor 2, factor 3, but what is it? What is it here? We have to give names of this factor. This is most difficult step because here we have no equations, we have no numbers, we have no strict rules. Here we must read the items and must guess what is it. Interested, proud, determined, active, strong, inspired, attentive, excited, enthusiastic, alert. What is this? What is the common phenomenon, or the common scale, or the common subscale? How we can name this factor? Suggestions? Ideas? 1, 2, or subscale 1, subscale 2, 3. Factor 2, scared, afraid, nervous, jittery. Factor 3, upset, ashamed, distressed, hostile, irritable, guilty. Any suggestions about the names of the factors? Do you hear me?
Maybe the first one is P because they're mostly positive emotions. The second one,
sorry, positive emotions?
yes, for the first one, because they have a sort of a common theme but it's difficult to encompass them under a single name.
Okay. The second?
Uh, fear, probably fear
Fear. Okay.
emotions.
Fear. Is this the correct fear? Yes, I think. And third?
Negative, let's say, just as a working
Negative.
one.
Okay. Okay. So I already said that this step is most difficult because there are no strict rules how to give these names. Different researchers will give different names, maybe. These different names will be close, but will remain different. So here I will agree with you, and I will use yours names of these factors. So in PSPP, factor analysis stops here. This is the end of factor analysis in PSPP. In SPSS, we can continue factor analysis with one more step. And this step is to create new variables, to create, in our case, three new variables for the three different factors, or for the three different subscales. So here we have button scores, and we can choose here save as variables. Then in the file will appear three new columns, factor 1, factor 2, and factor 3. And these values here are standardized values as z-scores. So we can see here for the first person that according to the factor 1, he or she is in the norm, because the value is 0.2, the value is between -1 and +1, and this person is in the norm. According to the second factor, the value is -0.1, again between -1 and +1, and according to this second factor, this person is also in the norm, and the same for the third factor. And in our case, you decide that first factor is positive emotions, second factor is fear, and third factor is negative emotions. So this person number 1, is in the norm according to the all three factors. For example, this second person is in the norm according to positive emotions and negative emotions, but he or she is above the norm according to the fear. So here, person number 6, he or she is below the norm according to the positive emotion and fear, but he or she is above the norm according to the third factor, to the negative emotion, and so on and so on. These values here are z-scores, and their interpretation is as z-scores from the previous topic. So this is the last step in SPSS. So this was shortly, briefly, presentation for the factor analysis. Questions?
Maybe I have one question.
Okay.
In the end, when we need to complete the task for the exam, if we have only access to PSPP, then should we stop to an earlier stage in the factor analysis?
Yes. If you have only PSPP, you will perform only 3 basic steps of factor analysis. I will repeat again. First step is identifying or determination of the number of factors. The step 2 is identifying or determination of correspondence between items and factors. And step 3 is giving the name of factors. Only this.
Okay, thank you.
Okay. Other question? Okay, I will stop the recording.